Now, question number 1 says, complete the table below by giving the IUPAC, that stands for International Union of Pure and Applied Chemistry, systematic name or the structural formula for each compound. Okay, either the IUPAC systematic name or the structural formula. Now, over here, if you look at this molecule, you can see that the carbon chain has got 3 carbon atoms in it. And it's an aldehyde because, as I'm pointing to it here, you can see it's got the aldehyde functional group at the end. Now, what's the systematic name for a 3-carbon aldehyde or 3-carbon alkanal, if you like? That's going to be meth-eth-prop-propanal. So it's going to be named based on it being a propanal. Now, if you look at this longest carbon chain here, you will see that it's got, we number the carbons, making the principal functional group carbon, the smallest number, when we get to there. So, that carbon atom here is the 3rd carbon atom, which carries the OH group substituent here, the hydroxy group as a substituent. So therefore, the systematic name will be 3-hydroxypropanal. So that will be 3-hydroxypropanal. Then we have to draw the structural formula that corresponds to propanamide. I think to save us some time, I'd already drawn that here. When we say propanamide, it's again the 3-carbon chain corresponding to propane, meth-eth-prop, and it's the amide functional group this time. Now the amide functional group is this one here, C double bond O connected to an NH2. So that's the amide functional group, and it's got 3 carbon atoms in total, 1, 2, 3, and that's what I have drawn out the structural formula here. Then look at the next one here. Now here we have 1, 2, 3, 4, 5 carbons in the chain, and it's an alkanone because it's got the C double bond O functional group here. Okay, 1, 2, 3, 4, 5 carbons in the chain, and it's an alkanone, but it's also got a metal group connected to it. You always number the chain in the way that gives the principal functional group the lowest number. So that's going to be the alkanone functional group, and you therefore be numbering from the left hand end, which gives it a number of 2, instead of the right hand end, which would give it a number of 4. So therefore we number as I have marked them here from the left hand end. And it's a 5-carbon alkanone, which makes it a pentanone. And a what pentanone? It's the pentanone where ketone or alkanone functional group is on the 2nd carbon. So it's a pentan-2-one with a metal substituent, that's a CH3 substituent, on the 4th carbon. So the systematic name then becomes 4-methyl. In the prefix of the name, we begin by indicating the position numbers for those substituents and what they are. So it's a single metal group on the 4th carbon, 4-methyl. And it's the pentanone, 5-carbon alkanone with that alkanone functional group on the 2nd carbon. 2-methyl pentan-2-one. Any questions, anybody? When are we supposed to use hydroxy instead of the ol suffix? Okay, 3-hydroxypropanal. Now, this is because, Edward, the hydroxy group here is a substituent group, because there is a more important functional group than the alcohol functional group in this molecule. So here, we don't name this as an alcohol, we name it as an alkanal. So you make this functional group, the alkanal functional group, to have the lowest number, the number of 1, and that makes the OH substituent to be on carbon 3. So this is named as an alkanal and not as an alkanol. So that is why it's 3-hydroxypropanal. okay, and not a propanol of some sort. Alkanoid chlorides and alkanoic acids, they are right at the top of the importance in the functional groups as far as this nomenclature goes. Alcohols and amines are lower than that, and that's why they are named as substituents when both these things are there in a molecule such as this. Okay.